Now, good day, ladies and gentlemen. Today we are going to look at diversification. Specifically, we are going to look at the proof for diversification, right? So, the idea behind diversification is that what happens when you are including more and more assets in your portfolio? Are you able to reduce the risk? And that is the purpose of diversification. Is that when you are diversifying, is that you are trying to reduce the risk. I mean, like that is the theory under the mean variance portfolio. Is that when you are adding more and more assets in your portfolio, the reason why you are doing that is that you are trying to reduce or maybe you are trying to reduce your exposure to risk in the market, right? So can we show this mathematically? So previously we have shown that if you want to find the risk of a portfolio, you're gonna find it like this. So it's gonna be the sum of I is gonna be equals to 1 all the way to n. You would have the weight I supposed to be I squared j, right? And then you would have plus the sum of I, and then you would have, let's just say this one is going to be j, and then you would have I not equals to j, right? And then you would have your weight of I and then your weight of j, and then the covariance between asset I and asset j. Now before we can go forward, we need to make some assumptions. Now the one assumption that we're gonna make in order to simplify our equation is that suppose that the weight of each asset is going to be equal to 1 over n, meaning that they have equal weight, right? And now suppose again, for simplicity, that the covariance between asset I and asset j is going to be equal to s squared, right? So this is just for simplicity's sake, right? And again, for simplicity again, we will just post that the variance of any asset is going to be, they are going to have the same variance. Well, we just call it sigma squared. So this is to just simplify our equation. So in other words, the variance of our portfolio is going to be what is going to be the sum of, now you have your weight of I squared, so which is going to be 1 over n, right, squared, right? And then you would have your sigma, right, because that's the variance of the portfolio of each and every portfolio, right? And then you would have the sum. This is for j, this is for I not equals to j, right? And then you would have again your 1 over n squared, and then the covariance of the asset, this covariance over here, we say that is going to be equals to s squared, so you will just write it as s squared, so you'll just have s squared, right? Okay, fine. So we can even try to simplify it further. We can say that this thing is going to be equals to n, so because this is the sum of n variables, so these are n variables, right? So you would basically have like n over n squared sigma squared plus, now you have n variables over here, and then you would have n minus 1 variables over here, because your I is not going to be equal to your j. So this is how you would write it. You would write your n minus 1 variable 1 over n squared s squared. Okay, so as you can see, I'm gonna write it again in the next page, right? I'm gonna write it again in the next page. I will say that the variance of your portfolio is basically going to be your 1 over n sigma squared plus n minus 1 over n s squared, right? And then how do you simplify this equation? If you want to simplify it, you can do this. You can have 1 over n sigma squared plus s squared, and then you would have the n over n s squared, so you just have the s squared. So as you can see, if you are going to add more and more and more assets in your portfolio, that is, in other words, if your portfolio, the portfolio risk Sn goes to infinity, is going to be equals to 0, right? So you know that the limit of n of 1 over n is going to be 0, right? As n increases, you know this from calculus, that as 1 over n increases, its limit is going to be equals to 0, and therefore you are able to write this thing as 0 plus s squared. So basically your s squared, which is the covariance between the asset, is the systematic risk. This is your systematic risk. Systematic risk. So this is the risk that cannot be diversified away. Okay, let me show you here. So basically, as your variance goes to infinity, you would have your risk like this, right? So that is the risk that cannot be diversified away, right? So if you are going to look at the risk, let's say as n increases, right? So n increases going that way, and then this is the risk of a portfolio, right? So you would see that there's gonna be s such that when you are adding more and more asset in your portfolio, your risk is gonna approach s, and s, as you can see, you cannot go below s because this is the risk in the market, so it cannot be diversified away, right? And we already know that, okay, this systematic risk is basically the covariance of the asset, of each and every asset, right? So we know that, okay, yes, so basically this is the risk that you are going to be exposed with. Be exposed to, because it's the market risk. So another thing that you should take into consideration is that, okay, let's say maybe you are trying to make sure that really your variance is going to be equal to 0, right? It's going to be s squared. Let's say maybe you are really trying to make it equal to 0, right? So it means that, again, another thing that you should take into consideration that is that since s squared is going to be equal to the covariance between asset I and j, where j is not equal to I, what you would do is to find asset, is to add asset which are uncorrelated in your asset, in your portfolio. So if you add assets which are uncorrelated, to say that assets are uncorrelated, it means that they have a correlation coefficient of 0. And if the correlation coefficient is 0, then it simply means that the covariance of asset I and j is also going to be equal to 0. So if that's the case, it means that as you include more, as you add more and more assets in your portfolio which are uncorrelated, your systematic risk should actually be approaching 0, right? So if that's the case, you are able to write this equation like this. So you are able to write it in this way. So you can write it in terms of a graph and say that, okay, Sn goes to increase, the variance of our portfolio is gonna be approaching to approaching 0. So this is what we mean by diversification. So this is the proof of diversification. This is how you show diversification mathematically. So I hope you have enjoyed this video. Please like, share, and subscribe. And we are going to deal in detail about the content when we meet for our exam preparation session, or for whatever session that we are going to have in the future. So please do subscribe, share my video. Thank you. Enjoy.